Hey everyone, and welcome back for another deep dive. You ready to explore something totally mind-bending with me today?
Always up for a challenge.
All right, good. Because today we're going on a journey to the heart of some of the most extreme objects out there in the vast universe, neutron stars.
Neutron stars, yeah.
And get this, these stars, they have earthquakes. Well, not earthquakes exactly.
Not quite.
But
Some cooler.
way cooler.
Yeah.
So imagine you're taking like the entire mass of the sun and squeezing it down into a space the size of Manhattan. That's how dense these neutron stars are. Can you tell us more about these cosmic heavyweights? Why are scientists so obsessed with them?
Oh, they're the remnants of massive stars that have gone supernova. And the conditions inside them, they're so extreme. It's like they're a giant physics experiment, one that we could never, ever replicate here on Earth.
See, that's what blows me away every time. It's like we have these cosmic laboratories out there that we get to observe. But if these neutron stars are so incredibly far away, how do we even study them, let alone sense something like a starquake?
Okay, so that's where things get really ingenious. Scientists are using these starquakes, these tiny vibrations, like fingerprints, to unlock the secrets of what's happening deep inside.
Okay, I like that analogy. It's like listening to a bell ring. And just from that sound, you can tell what it's made of. So these starquakes, what secrets are they telling us?
Well, they're helping us to test some of our most fundamental theories in nuclear physics, like Chiral Effective Field Theory. This theory tries to model how matter behaves under extreme conditions, the kind of conditions you would find inside a neutron star.
Hold on, so you're saying that these tiny little vibrations from a star millions of light years away could actually tell us something about the very building blocks of matter?
Yeah, pretty much.
Right here on Earth.
It's the amazing thing about science, right? It's all interconnected. When we study the extreme, we gain insights into the fundamental laws that govern everything in the universe, even us.
So what happens if the starquakes don't match up with what this theory predicts?
Oh, well, and things get really exciting. It could mean we need to revise our understanding of nuclear physics.
Oh, wow.
Potentially opening up a whole new realm of scientific discovery.
You've got me hooked. But before we go any further, I want to make sure I understand the basics. What exactly causes these starquakes in the first place?
Well, there are a few theories. It could be something as dramatic as a massive explosion on the surface of the star, or it could be caused by the gradual buildup of stresses within the star's incredibly dense interior.
So we're talking about forces so powerful they can shake a star made of the densest material in the universe.
Yeah, it's pretty mind-boggling.
Yeah, it's hard to even wrap my head around that.
It is, but that's the beauty of studying these extreme objects, right?
Yeah.
They push the limits of our imagination and force us to rethink what we thought we knew about the universe.
That's why I love these deep dives. You always learn something new and totally unexpected. All right, I think we've laid a solid foundation for understanding neutron stars and these fascinating starquakes. Now I'm dying to know, what does this all mean for us down here on Earth? That's what we'll be exploring in part 2.
Welcome back, everyone.
All right, so last time we left off with this incredible idea that by studying starquakes, we can actually learn more about the building blocks of matter, even here on Earth. I'm really curious to see how that translates into like tangible benefits for us. So what are some ways this research could impact our lives?
Well, one area where this knowledge could have a huge impact is in healthcare. Imagine a world with even more effective cancer treatments.
Oh yeah, sign me up for that. But how exactly do starquakes connect to treating cancer?
Okay, so think about radiation therapy for a sec. It uses high-energy particles to target and destroy cancer cells.
Right.
But those same forces at play inside neutron stars, the ones we can study thanks to starquakes, they're also key to understanding how radiation interacts with matter at a fundamental level.
I see. So by studying starquakes, scientists could learn how to manipulate those forces even more effectively.
Exactly.
Leading to safer and more targeted radiation therapies.
Precisely. It's like fine-tuning a really powerful tool, making it more precise and minimizing the damage to healthy tissue.
Wow, that's pretty amazing. Something happening millions of light years away could lead to more effective cancer treatments here. What other areas of healthcare could benefit?
Well, medical imaging is another really exciting possibility. Neutron stars are so dense that they give us this unique opportunity to study how radiation interacts with matter under these super extreme conditions. And the insights we get from that could lead to medical imaging techniques with much higher resolution.
So instead of blurry images, we could have crystal clear pictures of what's happening inside the body.
Exactly. Imagine being able to detect diseases way earlier
Yeah.
and with much greater accuracy.
That's the potential here. So we've got potential impacts on healthcare. You mentioned security earlier. I know this is kind of a sensitive topic, so let's tread carefully. What are the security implications of all this research?
Well, as we discussed, this research helps ensure the safe and secure maintenance of nuclear weapons. It all boils down to understanding how nuclear materials behave under extreme pressure and temperature, like the kind of environment you would find inside a neutron star.
So by studying starquakes, we can learn more about how to safely manage these really powerful forces
Exactly.
and reduce the risks associated with nuclear weapons.
You got it. It's all about using scientific knowledge to promote global security and stability.
Yeah.
But of course, we have to acknowledge the ethical considerations whenever we talk about nuclear weapons, right?
Mm-hmm.
It's important to remember that the research itself is neutral, but the knowledge we get from it can be applied in various ways, some of which raise some complex societal questions.
Right. It's a powerful tool that needs to be handled responsibly. But for now, let's get back to the science. You've highlighted healthcare and security. What about the impact on energy? Is that where things get really futuristic?
Oh yeah, absolutely. This research could unlock cleaner, safer, and much more efficient forms of nuclear energy. It's not just about improving existing reactors. It's about potentially developing entirely new ways to harness this power.
Okay, now you're speaking my language.
Well-
Tell me more about this futuristic energy landscape. How exactly do starquakes play into all of this?
Okay, so imagine this. Neutron stars. They're basically giant nuclear reactors in space.
Wow.
They're powered by nuclear fusion, the same process that fuels our sun.
Okay.
And by studying starquakes, scientists are able to get these little glimpses
Yeah.
into how fusion occurs under incredibly extreme conditions.
So it's like, until we're reverse engineering a star to solve our energy problems. I mean, that's incredible. Fusion energy has always felt like it's just around the corner, for decades now. Why should we be more optimistic this time?
Because starquake research is giving us this brand new data and insights. That could help us overcome some of the biggest obstacles in fusion research. Imagine finally cracking the code of fusion power, creating a world with clean, sustainable energy that's practically limitless.
That sounds like a dream come true. But let's be realistic for a second. What are some of the challenges and roadblocks that could stand in the way of this energy revolution?
Well, developing fusion power is a really complex and demanding endeavor. It requires global collaboration, significant investment, and a commitment to long-term research and development.
It's not going to be easy. But it sounds like Starquake research is giving us a brand new roadmap for a more sustainable energy future. And that's something worth being excited about.
I completely agree. Speaking of exciting new directions, I think it's important to highlight how this research is bringing together these two seemingly very different fields, astronomy and nuclear physics.
That's a great point. It's amazing how studying something as vast and as distant as a neutron star could have implications for understanding the tiniest particles that make up matter.
It really is a beautiful example of how science is all interconnected. Astronomers are making these observations about these distant stars, and those observations are giving us crucial data that nuclear physicists can then use to test and refine their theories.
So it's like this cosmic collaboration
Yeah,
with each field informing and inspiring the other.
exactly. And that collaboration is only going to keep growing. As research into starquakes continues, we're truly on the verge of a new era of scientific discovery, one that's driven by the convergence of these two fascinating fields.
Yeah, this has been an absolutely mind-blowing journey so far. I mean, we've covered so much ground, from the incredible density of neutron stars to the potential for these revolutionary new energy sources. And we've seen how this research is bridging the gap between what seem like very separate fields of science. Welcome back, everyone, for the final part of our deep dive into these incredible starquakes. It's been a wild ride so far, hasn't it?
It really has.
We've learned about these incredibly dense stars, the tiny little tremors that ripple through them, and how all of that research is giving us insights into everything from treating cancer to the very nature of matter itself.
And the amazing thing is, we're really just scratching the surface. There's still so much we don't know about neutron stars and the extreme physics that govern them.
Okay, so what are some of the big unanswered questions that are keeping scientists up at night?
Well, one of the biggest mysteries is the exact composition of a neutron star's core. We know it's incredibly dense, but what's it actually made of at that subatomic level?
So is it just a sea of neutrons, or could there be even weirder stuff in there?
That's the million-dollar question. Some theories suggest it could be a soup of strange quarks, which are even more fundamental particles than protons and neutrons. Or maybe it transitions into something even more exotic, called a quark-gluon plasma, a state of matter that existed just fractions of a second after the Big Bang.
Whoa, so we're talking about peering back to the very beginning of the universe here. But how can we possibly figure any of this out? It's not like we can just send a probe to the core of a neutron star.
That's where starquakes come in. By analyzing the patterns of these vibrations, scientists are hoping to decode the properties of matter under these super extreme conditions.
So it's kind of like using earthquakes to study the Earth's interior, but on this cosmic scale.
Exactly.
So it's cosmic detective work, using these tiny little tremors to unlock the secrets of some of the most extreme environments in the universe.
It really is. It's a testament to human ingenuity, how we can use these subtle signals from across these vast distances to understand the fundamental building blocks of matter.
It's pretty mind-blowing stuff, and it really makes you think about our place in the cosmos, you know? Here we are on this tiny little planet, studying these incredibly powerful and distant objects. It's both humbling and awe-inspiring at the same time.
It puts things in perspective. We're part of something much larger than ourselves, a universe filled with wonders we're only beginning to understand.
So what's next for this research? What are some of the future possibilities that have scientists excited?
One really exciting avenue is the search for gravitational waves from starquakes. When a neutron star undergoes a dramatic shift, like during a starquake, it can create ripples in space-time itself. And these are what we call gravitational waves.
Wait, so we could actually detect the space-time ripples from a starquake?
That's the goal. And it's not just science fiction anymore. With this new generation of gravitational wave detectors coming online, we're on the cusp of being able to observe these incredible phenomena.
That would be like having a whole new sense, a new way to perceive the universe.
Exactly. It would open up a whole new chapter in our understanding of neutron stars and the extreme physics at play within them.
This has been an absolutely amazing deep dive. We've explored the incredible density of neutron stars, the subtle vibrations of starquakes, and how this research is giving us insights into everything, from cancer treatments to the very nature of matter itself.
It's really a testament to the power of human curiosity and the interconnectedness of science. You just never know where a question might lead, or what amazing discoveries lie just around the corner.
Absolutely. So to all our listeners out there, keep looking up at the stars, keep asking those big questions, and keep diving deep into the wonders of the universe. Who knows what incredible secrets are waiting to be uncovered out there? And until next time, keep looking up and keep on diving deep.